It takes uncompromising strength to withstand the forces of nature. It takes Presto's multi-component GeoWeb cellular confinement system. The GeoWeb system is a high-strength polyethylene cellular structure of different depths and cell sizes that works with nature to prevent the movement of soil in all cellular confinement applications. The system confines infill horizontally to nearly vertical, from static, dynamic, hydrodynamic, and gravitational forces. Presto's advanced system features include perforated cells, tendons, and atraclips. The perforated GeoWeb system contains holes specific in size, quantity, and spacing for improved lateral drainage, greater cell infill lockup of aggregate and concrete, increased root lockup in a vegetated system creating a stable mass, a healthy soil environment that allows passage of nutrients and insects from cell to cell, reduced installation and maintenance costs. And because it's 16% lighter, it's easier to handle while still maintaining joint strength. Polymeric tendons facilitate in anchoring sections to embankments and slopes and provide stability against gravitational and hydrodynamic forces. They're also useful when a geomembrane underlayer or hard soil or rock prevents anchoring with stakes. The atraclip is used as an end cap to a straight rebar stake. The atraclip stake holds the GeoWeb system down to resist sliding and uplift forces. It eliminates the task and cost of forming J-pins and provides an inline, easier-to-drive anchor pin. As a restraint pin, the atraclip transfers load forces from the cell wall to the tendon. The GeoWeb system provides superior results for all soil stabilization applications. No matter what the problem, Presto has the solution. In load support applications, the GeoWeb system distributes loads laterally, reducing pressure and minimizing deformation and settlement. Perforations increase the friction angle between aggregate infill and the cell wall for greater system stability. Confinement of infill improves load distribution on paved and unpaved yards and over soft subgrades. Because pressure is distributed throughout, deflection and rutting are greatly reduced. The perforated system allows lateral cell-to-cell drainage beneath the traffic surface, reducing the negative effects of cell ponding. For applications with fine-grain infill, the textured GeoWeb system improves performance by increasing friction between the cell wall and infill. The stable GeoWeb system resists long-term deformation. In fact, base materials may withstand 10 times the number of recurring loads before accumulating harmful deflections. As load support problems are solved, construction activities often create steep or unstable slopes. In slope protection applications, infill is confined to resist rainwater runoff forces, erosion, and sliding of embankment materials. Perforations aid in drainage, and in saturated conditions, an overall weight reduction of the infill reduces downslope sliding. Tendons with the atraclip stake provide additional stability, especially on steeper slopes. When anchoring with stakes isn't possible, tendons with the atraclip restraint pin and deadman anchors provide the required stability. Vegetation is an attractive form of protection for slopes exposed to erosion. The perforated GeoWeb system reinforces the vegetation and allows root growth from cell to cell, resulting in a stable, environmentally healthy system. For slopes exposed to severe hydraulic or mechanical stresses, concrete provides durable protection. Perforations allow cross-cell flow of concrete, and due to the defined GeoWeb cell depth, concrete quantities and costs can be controlled. The GeoWeb system helps resist erosion of granular materials and permits their use on steeper slopes. the system also eliminates the need for complicated, expensive construction techniques. Many times, when slopes become very steep or almost vertical, the GeoWeb system can be stacked to form an earth retention system, ideal for tight space constraints. Horizontal terraces are formed where vegetation can flourish, and colored face panels blend well with the environment. The perforated GeoWeb system enhances performance by facilitating drainage of retained soils, resulting in a lower wall mass and a more economical wall structure. The GeoWeb material is durable, meeting all engineering requirements. And because native infill may be acceptable, GeoWeb systems are very cost-effective. Runoff from load support areas, slopes, and walls may require channel protection. The perforated GeoWeb system confines and reinforces the infill, creating a flexible liner in channel protection applications. A vegetated system is ideal in areas of low to moderate short-duration flows and when aesthetics are important. Roots penetrate into the subsoil, anchoring the system. Aggregate may be used in channels where flow velocities and durations are low to moderate. Concrete protects channels exposed to severe hydraulic or mechanical stresses. Tendons and attraclips provide additional stability against hydrodynamic forces. Stacked vegetated sections are used for steeper embankments and offer a natural appearance with the ability to withstand higher flows for short durations. The GeoWeb system is simple to install and powerful once it has been embraced by nature. Construction is easy in all applications, and Presto provides support during installation. The GeoWeb system is backed by years of research and testing with in-ground experience since the early 1980s. And you get more than a product. You get a solution, a complete engineered solution. You can have confidence in the Presto team. You get support from design through installation. And Presto supplies specifications, drawings, and other design tools. Discover how Presto solves problems with its unique product advancements, the perforated system, tendons, and attraclips, and how the GeoWeb system allows you to work with the forces of nature. For load support, earth retention, slope protection, and channel protection. From concept through construction, flexible, secure. You can have confidence in Presto's GeoWeb cellular confinement system. And when properly installed, the GeoWeb system provides stable, aesthetically pleasing earth retention structures. The simplicity of installing Presto's GeoWeb system begins with the ease of unloading it. Sections are typically shipped from Presto, tri-folded on a pallet, and are easily offloaded with forked equipment. Retaining walls are constructed with the GeoWeb sections in one of two orientations. Walls where GeoWeb sections are oriented so the cell surfaces form the fascia are referred to as A-series walls. Colored face panels, such as tan or green, can be applied to GeoWeb sections for aesthetics in this series. Walls where the cell fins form the fascia are called B-series walls. B-series sections allow greater flexibility when making curves. Start by preparing the site to construction drawings. Prepare a smooth, even surface, removing any debris or vegetation and filling voids. As required, compact the subgrade before placing the wall footing. Excavate for the footing and, when specified, install a geotextile separation layer before placing any base material. Then place, shape, and compact the granular base materials according to specification. Fully expand the GeoWeb footing section into position with temporary or permanent anchors, stretching devices, or by other workable methods. Place the specified infill material in and around the footing section to a level about 50 millimeters or 2 inches above the cell wall. Level and compact the infill material using appropriate compaction equipment. If specified, place additional fill over the footing section to obtain the required elevation. Groundwater drainage can be critical to the performance of any wall system. Be sure a proper drainage system is installed. When expanding wall sections, use tools specifically dimensioned for each section size to hold the expanded GeoWeb section in shape prior to infilling. Use stretcher frames when wall faces are straight or have little curvature. Expand the GeoWeb section so the end cells are hooked over the frame pins. Next, invert the frame and position the section in place or next to an adjacent section. Use stretcher bars when the wall face curvature is more pronounced. Place the bar's front pin in the front cell and expand so the back pin is in the back cell of the same row. A stretcher bar should be placed in every row of cells. Once sections are in position, staple adjoining sections together. When curves are a part of the wall design, adjust the GeoWeb section to give the required curvature. When a specific angular deflection occurs, use tapered GeoWeb sections. Several methods work well for creating both inside and outside corners. One method to form inside corners is overlapping. Overlap two GeoWeb sections to create the desired angle. One section may need to be partially collapsed when the angles are greater than 90 degrees. The most common method used to form outside corners is wedge removal. Remove a wedge of material from the GeoWeb section equal to the angle of deflection. Be sure not to cut the fascia panel. Then join the two cut edges and staple them together to form the modified section. Once the GeoWeb sections are in position, you may begin infilling. First, place the infill material inside the GeoWeb section and then behind it to the excavation face or embankment limit. Overfill the cells and level to about 50 millimeters or 2 inches above the cell wall. Then remove the stretcher frame or stretcher bars, repeating the process for all adjacent sections. Use lighter compaction equipment to compact infill within the GeoWeb section. Then compact backfill materials directly behind the wall sections to specification. Heavy compaction equipment can be used to compact backfill materials to within 1 meter or 3 feet of the wall sections. Monitor the front face cell alignment between the compacted layer and layer beneath to determine if movement is occurring. If there is movement, compaction equipment may be too close or applying too much compactive pressure. After each level is compacted, remove excess materials so the tops of the GeoWeb cells are visible. When positioning subsequent layers, 2 alignments are important. First, maintain proper side-to-side cell alignment to prevent infill loss. Second, maintain the proper setback according to design. When the retaining wall is a geosynthetic reinforced structure, install the specified woven geotextile or geogrid between the GeoWeb layers at the specified elevations. Position the geosynthetic reinforcement so the leading edge is 100 to 150 millimeters or 4 to 6 inches from the front cells and extends horizontally into the compacted backfill area. Place and infill the next GeoWeb layer. Tension the reinforcement by pulling it back from the infilled wall sections. Finally, place backfill over the reinforcement and compact it. Infill and compact subsequent layers following the same procedure until the specified wall height is achieved. When a special fill, such as topsoil or concrete, is required in the front outer cells, several methods are used for infilling. One method is to cover the outer cells with boards. Place the boards over the stretcher bars during the filling of the back cells. Once the back cells are filled, remove the boards and fill the front cells with the specified infill. Then remove all stretcher bars. Another method uses a specially configured stretcher frame that allows the front cells to be covered during infilling of the back cells. After infilling, remove the stretcher frame. The front cells are now ready for infilling with the selected material. There are many workable techniques for constructing earth retention structures. Contact Presto or an authorized distributor for more information. From construction start to finish, Presto works with you to provide solutions to earth retention problems. Cost-effective solutions you can rely on. Strong, flexible, secure. You can have confidence in Presto's GeoWeb cellular confinement system. And when properly installed, the GeoWeb system provides dependable soil stabilization solutions. Solutions for slope and channel protection, load support, and earth retention applications. The simplicity of the GeoWeb system begins with the ease of unloading it. Sections are typically shipped from Presto, tri-folded on a pallet, and are easily offloaded with forked equipment. Start by preparing the site to construction drawings. Prepare a smooth surface, removing any debris or vegetation, and filling surface voids. On slopes and channels, excavate anchor trenches along the crest of the slope. When specified, install a geotextile over the prepared surface. On slopes and channel inverts, place the upper edges of the geotextile in the anchor trench at the slope crest and unroll it down the slope. In channels, overlap the geotextile in the direction of flow and secure it. On flat surfaces, expand the GeoWeb sections and hold them in place with temporary or permanent anchors. To connect sections, align and interleave the sides of adjoining GeoWeb sections so they're flush, then fasten them together with a pneumatic stapler. A stretcher frame keeps sections expanded when dimension tolerances are important on flat surfaces, such as for retaining walls, underwater applications, or in freezing conditions. Expand the GeoWeb section so the end cells are hooked over the frame pins. Next, invert the frame and position the GeoWeb section in place or next to an adjacent section. Once positioned, interleave the sides of adjoining sections and staple them together. Infill the GeoWeb sections with specified material, removing the stretcher frame only after the section is backfilled. When anchoring sections at the crest of a slope, use a template with a series of cut V-notches located at every cell of the expanded section to simplify marking the stake position. Along the anchor trench or embankment crest, place an ATRA anchor where each GeoWeb upper end cell is to be located. Presto's ATRA clips, used with ATRA stakes, form the ATRA anchoring system. Pre-assembled glass fiber reinforced polymer anchors are also available from Presto. To avoid hand contact with stray glass fibers, gloves should be worn when handling the glass fiber ATRA anchors. First, partially drive each ATRA anchor into position. Place each of the GeoWeb upper end cells over the anchors, making sure the section will expand down the slope. Align the ATRA clip arm over the cell wall and drive the anchor until the clip comes in contact with the cell wall. Fully expand the GeoWeb section down the slope, repeating the process for subsequent sections. Next, interleave adjoining cells of opposing sections and staple them together. Hold the sections in place at the bottom by driving anchors perpendicular to the ground. All stapling and anchoring can be done simultaneously. If the incline is longer than one expanded section, staple the required sections together before expanding them. When tendons are used, align tendon holes before stapling the sections together. Then thread the tendons after all the sections are stapled. After expanding the sections, insert an ATRA anchor within the top row of cells of each adjoining section. Drive additional internal anchors into the expanded cells as specified. The GeoWeb system can cover odd-shaped areas, such as curved surfaces or corners, simply by altering the section. Two methods are used. For the first method, vary the degree of cell expansion along the length of the GeoWeb section. Do this by under-expanding one side and over-expanding the opposite side of each section. For the second method, use a utility knife to cut the expanded GeoWeb section into two pieces along a diagonal string line. Rotate or flip one piece and realign it with the other. Then interleave adjoining cell walls and staple them together to form the altered section. When tendons are required, use GeoWeb sections furnished with pre-drilled holes. Pre-cut tendons to specified lengths. Tendons can also be applied directly from the spool to the GeoWeb section using the spool support system. With the GeoWeb sections collapsed, thread pre-cut stiff or coated tendons through the pre-drilled holes. For uncoated, more flexible tendons, use a short, stiff wire with an elongated loop at one end to act as a threading needle. With the tendons threaded, position the collapsed section at the crest of the slope. Two typical crest tendon anchoring methods are as follows. Method 1 uses the ATRA anchoring system. Make sure that stakes can be driven into secure ground at the specified distance from the end of the GeoWeb section and in alignment with each tendon location. Drive the ATRA anchors so the bottom of the ATRA clip is a small distance from the ground surface. Tie a non-slipping loop in the tendon large enough so it will fit over the ATRA clip. Then place the loop over the clip and secure it under the clip's arms. Method 2 uses a pipe deadman anchoring system. First, lay the specified pipe into its anchoring trench. Tie tendons securely around the pipe with a non-slipping knot to create resistance. Then pull firmly on the tendon to make sure the knot is secure. Next, backfill and compact the trench to secure the deadman anchoring system. For internal anchoring with tendons, place the ATRA anchors in the specified cells, removing any upslope slack. Next, fully drive the anchors perpendicular to the slope so that the arm of the clip passes over the tendons. Start from the uppermost cell and repeat the process for each ATRA anchor. For increased stability, secure the tendon with the Moore hitch. Place the tendon under one ATRA clip arm, cross it over the top and under the opposite arm. Then cross the tendon over the top again and pass it under the first arm. Some tendon types may require a double Moore hitch. When ATRA clips are used to transfer the load from the cell to the tendon, locate the cells where ATRA restraint clips will be placed. Starting from the uppermost cell and working down, remove the upslope slack from the tendon. Place the ATRA clip so it's against the upslope cell wall with the tendon passing under one arm. Next, secure it with the Moore hitch by crossing the tendon over the top of the clip and under the opposite arm. Then cross the tendon over the top again and pass it under the first arm. Moving down the slope, repeat the process for each ATRA clip, removing any upslope slack before tying the Moore hitch. ATRA restraint clips are typically positioned inside the uppermost cell and outside the lowermost cell of each section. When working on the slope is difficult or undesirable, ATRA restraint clips can be inserted in the cells of a fully expanded tendon GeoWeb section on a level surface. Once all clips are in place, position the collapsed section at the crest of the slope and secure the tendons to the crest anchoring system. Finally, expand the pre-assembled GeoWeb tendon restraint system down the slope. With the tendon GeoWeb system, toe anchoring is similar to crest anchoring with the ATRA anchoring system. Tie a non-slipping loop in the downslope end of the tendon and remove the upslope slack. Place the ATRA anchor through the tendon loop and fully drive the anchor perpendicular to the slope so the loop passes under the ATRA clip arm. After GeoWeb sections are secured for the application, infill is ready to be placed into cells with the appropriate earth-moving equipment. Make sure the wheels or tracks don't come in contact with the empty cell walls. On slopes, infilling is typically performed from the crest to the toe. Limit the drop height for all infill types to 3 feet for standard cells and 2 feet for large cells. If you notice any cell distortion, immediately reduce the drop height. Infill should be spread uniformly over the entire surface. Compaction requirements and equipment will vary with infill type. With many topsoils, place infill only to the top edge of the cells. Topsoils that require light tamping or rolling for stability should be overfilled 25 to 50 millimeters or 1 to 2 inches. Then tamp and remove excess infill so the soil is flush with the top edge of the cell walls. After the topsoil surface is prepared, additional erosion control products such as liquid applied mulches or tackifiers, straw, or erosion control blankets can be applied. With granular infill, overfill the cells 25 millimeters or 1 inch and compact the infill using suitable compaction equipment. If equipment comes in contact with the cell walls, add additional infill as needed. Generally, in slope and channel applications, excess granular infill is removed. Concrete infill can be placed into the cells directly from the ready-mix truck or from other concrete placement methods. On slopes and channels, concrete fill is placed from the crest to the toe to avoid downward cell distortion. Spread concrete evenly in cells so it's flush with the top of the cell wall. Then tamp it with manual or vibratory equipment. Finally, finish the concrete surface as specified. From construction start to finish, Presto works with you to provide solutions to soil stabilization problems. Cost-effective solutions you can rely on.